Hello everyone, welcome to the next video in the Django security series. And today we will learn how to implement a good password policy in Django. In the previous video, we had a look at the NIST SP 863B, which is a new set of requirements for a password. It is very different from the traditional password policy in that it does not enforces you to have special characters in your password. So it's not mandatory to have at all. Next is that it should contain at least 8 characters. However, it is recommended to make it as long as possible. Third, it should not contain sequential and repetitive characters. Next, it should not be context specific in the sense that this password should not be similar to username, the company name, the website name, etc. It should also not be a password that is commonly used. For example, admin@123. It's a very commonly used password. Also, finally, it should not be a password that is already breached. So since there are many requirements here, we will look at the first three. So one is with respect to the special characters, then the minimum length, and also not allowing sequential and repetitive characters. Let's consider the first thing, special characters. So the requirement is that it's not required, it is not mandatory to implement special characters in the password. So we don't need to do basically anything. So by default, Django accepts the special characters. What we are doing here basically is that we are going back on the traditional password policy, in that we are not enforcing the users to have a special characters in the password. So in this case, basically nothing is to be done. So let's go to the next requirement, minimum password length. So the NIST guideline recommends 8, but to be on the safer side, we will keep it as 12. The maximum length the password can have is 128. So if you go to the abstract base user model, you can see that the length of the password is mentioned as 128 characters. 128 characters, I think it's pretty long enough. So that would be the range, 12 to 128. Now let's go to the editor and see how we can implement this 12 character minimum password length requirement. I am here in the settings.py file within the project, and here, as you can see, there is a list called auth password validators. Okay, it contains basically a dictionary of password validators which will be used during the creation of password. So there are few default ones like user attribute similarity validator, minimum length validator, common password validator, and numeric password validator. So for the requirement of minimum length, as you can see, we already have a validator here. Okay, what we have to do is just mention that we want to have the minimum length as 12. So for that, what we can do is to add another key called options. Okay, so that is the second key. The first key is the name of the validator. Second is we are passing certain options to the validator, and in this case this is a dictionary as well. It says min length as 12. Okay, so that is the option that we are providing to the minimum length validator. So this essentially means that the minimum password length should be 12. Okay, so let's run the program and verify that the validator is working. So I have to log in, and let's say I want to change my password. The current password that I have is JERIN@123456789. Another very bad password, but that's what I have right now. Okay, now the new password, I'll just put something gibberish like 123456 and QWERT 123456 QWERT5. Okay, so how much in length? 1 2 3 4 5 6 7 8 9 10 11. Okay, it's 11. So it should not get accepted, right? because it's less than 12. Let's see. Yeah. So it has not accepted the password. It says that it must contain at least 12 characters. Okay. So that one particular requirement is now satisfied. So let's look at the next requirement. The next requirement says that any repetitive or sequential characters should not be allowed. So this means that anything that is repetitive like A or B or 1111, these kind of characters should not be allowed in the password. Second, there should not be any consecutively increasing integers like 1, 2, 3, 4. There should also not be any consecutively decreasing integers like 4, 3, 2, 1. There should not be consecutively increasing alphabets as well like A, B, C, D. And there should not be any consecutively decreasing alphabets as well like dcba. So this much at a minimum we can implement to ensure that repetitive and sequential characters are not there in our password. So for the implementation part, let's look at each of these requirements and see how we can implement them in a Django application. First, the repetitive one. So let's consider this is a password that I'm entering into the application. Okay, 1111 K7XFG, and we will keep the number of times that it is consecutively repeating as 4. Okay, so we will make it configurable like 3, 4, and 5. But in this example, let's consider that we are going to identify whether a particular character is consecutively repeating at least 4 times. To do that, the first step would be to look at each character from the left. So in this case, we'll start with 1. In the second step, we have to identify that that particular character, does it appear 4 times in the password overall, right? If it is not appearing 4 times overall in the password, is appearing only once or twice or thrice, then we don't need to check whether it is consecutively repeating, right? So that one check is what we have to do first. Third, if it is yes, if it is repeating 4 times, so in this case it will go and look at 1. It will then check whether overall there is 4 occurrence of the character 1. Does the character 1 appear 4 times or at least 4 times in the password? Yes, it does appear. It appears here, 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 and here. It does appear 4 times, right? Now, if that happens, we have to check if that character is appearing together, right? Example 1111. So whether it is consecutively repeating, that's what we have to check. If that case is true, then we have to raise an error saying that you do have consecutively repeating characters in the password and hence it is not allowed. To implement this new validation of disallowing consecutively repeating characters, we will create a new file called validators.py in our application folder. So let's create this called validators.py, and here we will write our password validation. A password validator is basically a class with at least 2 methods. One is called validate, the other is called get help text. So let's create such a structure first. Let's say class, I have to provide a name to this validator. So I'll say something like consecutively repeating character validator, something like that. Okay, I need to have at least 2 methods. So one is called validate and another is called get help text. Right? Since it's a method within a class, we'll put it as self. Right. So this is the basic structure of a validator. Okay. The validate method actually performs the validation. The get help text provides the help text to the user. We also said that we will make this validator configurable Now to do that, we'll have to initiate this class with the length of the check. So we'll provide something like self comma length as well. Okay, if we want, we can provide a default like say a 4. Okay, so it will check. If we don't provide any options, by default it will take 4. And which is a class self.length equals length. So for any calculations, I'll be using this value. So that's the initiation part. Next, we will write the actual validation. So we say that we have to look at each character in the password. Now, where do we get the password? It has to be passed here. Okay. Then we also have to provide user equals none. The validate method is expecting these two parameters. Now, we said that we'll have to go through each character. So we'll loop through each character. So we'll say for character in password, right? And the second step we said was we have to check if there are 4 occurrences or more than 4 occurrences of these characters. So I'll say if password.count of this character. Okay, so I'm checking what is the count of this character in the password. I'll get that value. If it is more than or equal to self.length, I will have to check whether it is appearing together. How will I do that? I'll make something like this, a variable check character equals the character times self.length. So what will happen? So for example, if the character is 1, it will see that the character 1 is appearing more than 4. I'll have a new variable called check character, which where we will assign 1 into 4. So 1 appearing 4 times. So 1, 1, 1, 1. Okay, this is a character. This is a string, not a number. So it will get concatenated, appended to the end. So it will be 1, 1, 1, 1 as a string. Okay, the password is also a string, right? Now I'll check if this check character is in the password or not. Okay, so if it is there, we need to raise a error. So for that, I need to raise a validation error. Okay, but I don't have this validation error as of now, in the sense that I will have to import it. I'll have to import it from exceptions. So from import validation error. Okay, so there I have that. I will just raise that validation error. So we will make it as it password contains characters that are consecutively repeated. And we'll provide some examples as well. Example 1111 or something like that, so that the user exactly knows why the password is being blocked, it's not accepted. Now, to ensure that as a best practice, these text get translated into the native language that is present in the system, we can add a translation here. To do that, we'll just import from the translations module. So django.utils.translation. We have to import get text, and as this, right? And we will just mention this way, right? So this is considered as the best practice, where we just translate whatever text we are mentioning here in the language that is there in the system. Now we have to also return a help text. So here also similarly we just mention return something like characters in the password cannot consecutively repeat. Some examples. Now we have to add this validator in the settings.py file. So let's go to the list auth password validator, and let's add a new validator. So name, this will be under app.validators dot the name of the validator, consecutively repeating this thing, right? We have mentioned the length as 4. If we want to change it, we can just have an options here and add a dictionary which says length is say 5 or something like that. Okay, we can mention it this way as well, but I am perfectly okay with 4 being the default, so I will remove that and only mention the validate. Okay, now let's go back to our application and see if it works. I'll refresh this page. Okay, so now I will enter the earlier password, and I will enter a password where it is consecutively repeating. So I'll say something like 11111 at the rate QWERTY, 11111 at the rate QWERTY. Okay. Here we have an error which says the password contains characters that are consecutively repeating, right? Now it has not accepted it. So the first requirement, the first validator is complete. We can now go on to the next validator, which would be to disallow any consecutively increasing integers. Let's consider the password like this: 1234 K7XFG. Okay, so to disallow such kind of a password, let's look at it step by step. As a first step, I'll go from the left. Okay, I'll start with the left, in this case with 1. Okay, and I'll loop through each of these characters, right? Now I'll first check if the character is a number. Is it a number? If it is yes, I'll check if the next number is the current number plus 1, right? So in this case, I'll check whether 2 is 1 plus 1. It is yes, that's correct. If yes, I'll repeat the same check for the next number. So for example, is 3 equal to 2 plus 1? Yes. If the scenario is true for more than or equal to 3 times, we will raise an error, because see, the first number is anyhow there. We are checking whether 1, 2 and 3 in this next 3 instances, whether this check is there or not, right? That would total mean that 4 numbers are consecutively increasing as 1, 2, 3 and 4, right? So this is how we will implement this check. Now let's go to the editor and implement this validator. I will name this validator consecutively increasing integer validator. So consecutively increasing integer validator. Yeah. Then same as before, I will initialize this. Now we will have to create the validate method. Now I'll have to start from the left. So I have to loop through each of the character in the password. So I'll say for character in password, I will first check like we discussed before, if the character is a number. So to do that, we'll see if character is digit. Okay, this is the function which we use to determine if the character is a digit or not. If the character is a digit, we will initialize the count as 0, right? So this is what we'll do the count. So like first check is correct, then we'll increase the count to 1 that way. Okay, count is 0. We'll get the number, the actual number. For safety, I'll just make it int of character, because the character is actually a string, right? So I'll just make it number, and index of this number of this character I will have to identify. So I will say password dot index of character, right? So these are the three initial variables that we have to define. First is the count, which we'll use later whenever add check is correct. The number, the actual number here, which is the integer of this character, because character is actually a string, and we have the index of this character, right, which will give the position of the character in the password. So the first index will be 0 in this case, right, because we are starting from the left. So for better understanding, let's consider that this is the password. Okay, right, I'll use this as a reference. Okay, now I have to, what the check I have to do is I have to first check if this is a digit and whether this is equal to 1 plus 1, right? So let me first loop through it. So I'll say for I in range 1 comma self dot length. Okay, so I'll loop through it once, and I will see if password of index plus I. Okay, so now this means that index is what? In this case, the first scenario is going to be 0, right? Because the character is the first character, in this case 1. So index is going to be 0. Now I have to check whether the next character, which is 2, with an index of 1, is a digit or not. So I'll check dot is digit, because if the next character is not a digit, then I don't need to worry about it, because I'm basically checking whether the next character is the current number plus 1, right? So if it is not a digit, I don't need to worry about it at all. So if the next character is also a digit, I am then checking if the integer value of the next character, so the index plus I, sorry, plus I, which is basically the same thing, right? The next value is equal to the number, which is this, right, plus 1. Okay, so that's what I'm checking. So I'm in, this is the place where I'm checking whether this 2 is 1 plus 1. Okay, if it is, if it is matching, if it is true, we'll increase the count by 1. So we'll say count is equal to 1, and I'll increment that number by 1 as well, right? Because now I have to check the next one, so I have to repeat the same test for this, right? So the current number in the next iteration will be 2, and I'm checking whether 3 is a digit. If yes, is 3 equal to 2 plus 1, right? That way, so it will iterate in that perspective, right? Now when this count is more than 3, more than or equal to 3, that's when we have to raise an error, because by then it would mean that we have considered these 3 characters at least, right? That means that at least 4 of the characters are consecutively increasing integers, right? So I'll write that condition which says while count, so this count is greater than or equal to self.length minus 1. Okay, so this is 4 minus 3 in the default case. If it is it is the count is greater than or equal to self.length minus 1, then raise the validation error. So same as before, you'll have to raise the validation error. Yeah, so that's when the error will come up. Okay, so altogether this is the core logic. Now the only problem will happen whenever this goes out of index, yeah, because we are looking through it and the password thing goes out of index. It will have a index error. So for that we'll just need to have it under the a try statement with index error. Okay, so you can try it without the try statement. You'll definitely get an index error. So to ensure that we don't get it, we'll just pass it. So let's go through it again. I'll have to loop through each of the character in the password. If the character is a digit, I will initiate count as 0. I will change the or convert the type of the character to a number and also get the index of this character. So in this case, it will be 0, right? Now I will loop through. Now I have to get do the two checks, right? One is the next number a digit? If yes, I'll have to check if the next number is the current number plus 1. If it is yes, I will increment the count by 1 and also the number by 1. So now it will have 2 as the current number and 3 as the next number, and it will check whether 3 is a number. It will say yes, 3 is a number, and then it will check whether 3 is equal to 2 plus 1. Okay, so it will keep on happening until these cases are true, and whenever the count is more than self.length minus 1, then it will raise a validation error. Now there is a chance that it might go out of range for the index, so we'll have to have an index error as well, so that error is handled. So let's add this validator to our settings. We can just copy from here and we'll say consecutively increasing validator. Right, let's go back to our application. Let's change the password again. Oh, we forgot to add the get help text. Sorry, let's add it. Yeah, let's go back, refresh. Yeah, so I add the previous password and I will add a password which contains 1 2 3 4, right? So it will be 1 2 3 4 @QWERTY. Let's say it has two errors. One is it is short, obviously, and then it also says that the password contains consecutively increasing integers. Example 1 2 3 4, because we had 1 2 3 4 in the password. Right now, this validator is also completed. Let's look at the next requirement, which is for disallowing consecutively decreasing integers. So let's take this example where the password is 4321K7XFG, right? Now the step is going to be the same in the sense that we'll have to start from the left. Here in this case, starting with 4, we'll have to check if the character is a number. The only difference here is we are checking if the next number is current number minus 1, right? So here we have to check whether the next number, which is 3, is 4 minus 1. If it is yes, we have to repeat the same check for the next number. So in the next scenario, it will be whether 2 is 3 minus 1. If such a case is true for more than or equal to 3 times, we'll have to raise an error. Let's go back to the editor and implement this validator. Okay, so I'm going to copy the same code as the increasing one because the code is going to be more or less the same. So I'll just copy here and just change the name to decreasing apart from increasing. Rest here is the same. The check is the same, whether it's a digit. Count is also going to be 0. The number is also going to be changed to integer type. here is also going to be same. The only difference is that we have to make this -1 and this will be number -1. Yeah, so that's only the change apart from this validation error. So it should be decreasing 4 3 2 1. For help text as well, we mention decreasing as 4 3 2 1. Now let's go to the settings and add the validator. So here everything is same apart from it being decreasing. Right, now that we have added it, let's go back to the application and enter the password. So the password I will enter here is 4321 @QWERTY. Save. Now two errors. One is that it is short, obviously, and the next is the password contains consecutively decreasing integers. Right, now that the validator has worked, this check is also completed. The next requirement is that the password should not contain consecutively increasing alphabets. Okay, so consider a password like this: ABCD K7XFG. Because it is containing A, B, C, D, which are consecutively increasing alphabets, this password should not be acceptable. Okay, so the step that will follow is similar to the previous one. We have to look at each character. So in this case, we'll start from the left with A. Then we'll have to check whether the character is an alphabet. Yes, if it is an alphabet, we have to check, okay, basically whether the next alphabet is, you know, the in the English alphabet, whether it is the next alphabet. Now, how do we check it in the program? That's why we will use ASCII values. Okay, so every character is assigned an ASCII value, right? So we'll check whether the ASCII value of the next alphabet is the ASCII value of the current alphabet plus 1. Okay, so that's what we check. So if you look at the ASCII table of alphabet from small letter A to small letter Z and capital letter A to capital letter Z, it looks something like this. Here you can see that the capital letter A has an ASCII code of 97, B has 98, C has 99, and so on till Z, which has 122. Okay, similarly, A has an ASCII code of 65, B has 66, similarly till Z, which is 90. Okay, so that's increasing sequentially, right? That's what we will use in our program as well. So if that check is true, we will repeat the same check for the next alphabet as well. And similarly, if the case is true for more than or equal to 3 times, we will raise an error. So if you see, more or less it's similar to the integer part. The only thing is that we are checking whether the next alphabet is like +1 to the previous alphabet by using the ASCII value. So let's go to the editor and implement this. I'll copy the same code as the increasing integer code. So I'll just copy here and make some minor modifications. First, I'll change the name as consecutively increasing alphabet validator. And instead of is digit, we have to check whether it's an alphabet, right? So we'll say it's alpha. Yeah, so we'll have to check whether the character is alpha. We don't need this because it's a string character itself, so that is okay. We'll remove this as well. And here it's also going to be is alpha instead of is digit. Here is where the difference comes. So instead of doing as integers with because it was number, we have to consider as a ASCII character, right? So to use the or to get the ASCII character of a ASCII value of a character, we use something called the odd function. Okay, so this will give the ASCII value of the next character in the password. So in this case, if the password is something like abcd@QWERTY, this will give the ASCII value of B, which is 98. Okay, and here we have to change it to odd of character. This means that it will give the ASCII character or ASCII value of A, which is 97. Okay, and this comes in integer format, so we can check whether 97 plus 1, okay, which is the 98, is equal to the ASCII value of B, which is 98. So 98 is equal to 98, and hence the count will be 1. Number is equal plus or equal to 1. This will change. Now we have to provide or we have to mention that the next character is going to be B, right? So to do that, we can just say character is equal to this is going to be B, right? So I can just say B here. But if you see, if this is a ASCII value, now to get the character from an ASCII value, we can just mention CHR of the ASCII value. That will provide you the character from the ASCII value. Okay, so this is how you can do it. Or instead of that, you can just add password index plus I. That is also okay. But I just wanted to explain how to get the character from an ASCII value. So I'm just using this. Okay. Rest is this is same. It will check whether it is greater than or equal to self.let minus 1. So in our case, it's greater than or equal to 3. When that error happens, we can just say the password contains consecutively increasing alphabets. Example A, B, C, D. Right? And yeah, we can just have to get the help text as well. Just copy from here. Next, we have to add the validator in the settings.py. So I'll just copy here, increasing alphabet validator. Yeah, now let's go back to the application. Refresh. Let's provide the current password, and the new password I'll provide something like ABCD @QWERTY. Save. Two errors. One is that it is short, and the other one is the password contains consecutively increasing alphabets. Right. So that validator is working. Now to implement the decreasing part, it's quite similar. We'll just copy from here and make some minor changes. First is the name, obviously, consecutively decreasing. This is same, this is same, this is also same. The only difference is instead of plus, it's going to be minus. Here as well, it's going to be minus. Rest everything remains the same. Just need to mention this dcba, decreasing, and dcba. Next, let's add the validator to the settings file. Just mention decreasing alphabet validator. Refresh, enter the current password. Now I will enter a password like dcba @QWERTY and save. Yeah, the validator is working. It's saying that it contains consecutively decreasing alphabets as well. Okay, so this is how we can implement this validator. Okay, so finally all these requirements have been implemented as validators, and that's it for this video. In the next videos, we will look at the remaining requirements of passwords not being context specific, of not being very common, and that it should not be breached. So stay tuned for those videos and please subscribe to my channel. Thank you.